time to learn about electron energy and light. Did you know that light has every color of the rainbow in it? Red, orange, yellow, green, blue, indigo, and violet. And if you separated that out of regular light, you'd have light that has a lot of energy and light that has very little energy. The reason why red's down here is because it's low energy. The reason why violet's up here is because it's high energy. Infrared is less than red, and ultraviolet is greater than violet. Red has low energy, violet has high energy. Let's find out why. Light travels in waves. And here are two examples of waves. Here's one wave, and here's another wave. Energy travels in waves. Which one would you say has more energy? Whenever you go from one point of going up to the next point where it's coming back up again, you've counted one wave. Notice that the length between the one edge and the other edge, that's called the wavelength. And notice that this wavelength down here is much longer than the wavelength between here and here. Okay? Again, it's where the wave is starting to come up, and here's where the wave is starting to come up, back up again, so that's considered one wave. So how many waves would you say are in here? There's 5 of them. There's 1, 2, 3, 4, 5 of them. Okay? Now, wavelength is longer here, but there's less of them. Wavelength here is shorter, between here and here, and there's a lot more of them. We call the distance between the 2 points of a wave the wavelength, and we call how many waves I have in there the frequency. So the top one has greater frequency, bottom one has less frequency. So the top one has more energy, the bottom one has less energy. Back to our rainbow here, this end would have a longer wavelength, less frequency, less energy. This end would have greater frequency, shorter wavelength, more energy. Okay? Greater frequency, greater energy. Less frequency, less energy. Now let's take a look at an atom. Atoms have electrons in them, and we already talked about how electrons have an attractive force. So this electron here has an attractive force for the nucleus, and the closer it is to the nucleus, the greater the attractive force. If you add energy to an atom in the form of heat, it could be electricity, electric shock, something like that, what you do then is you give an electron energy enough to go out to a higher energy level. So this electron, if it absorbs some energy, in this case it's energy in the form of light, if it absorbs this energy, this electron can now jump out to a higher energy level with that energy. But that makes that electron very uncomfortable and unstable because it's leaving behind some empty space or void. So what that electron wants to do, now that it's out here, remember it's in this level here, this electron wants to get back down into the void that it left and make the atom stable again. So once it jumps, how can it jump back down? It can't jump back down without letting go of that energy. And the only way it can let go of that energy is by releasing it. Whenever an atom releases energy, it releases it in the form of light. Okay? And what did we say about light? Some light has more energy than other light. So if an electron is coming from a very high energy level and dropping down to a very low energy level, there's going to be a lot of energy released. And if there's a lot of energy released, what color light do you think is associated with that?
Violet.
The violet. Very good. So if I have an element that has a lot of energy already in it, and I excite the electrons in there, when they jump down to lower and lower energy levels, they're going to release more and more energy, or more and more colors from our rainbow, from our Roy G. Biv. And that's what you're going to see in class. You're actually going to see examples of us energizing atoms and watching the color of light that will be emitted in different distinct In class, lines. We're going to take tubes of gaseous elements, add electricity to them to excite their electrons, and then see what type of colors are emitted through special glasses that you'll get to wear. You'll actually see the unique colors that will come from each individual element.